Before we move on to solving rational equations and inequalities, I actually want to spend a little bit of time going over the operations on rational expressions. So today we're going to be looking specifically at how to multiply and divide a rational expression. Here are some rules and things to keep in mind for whenever you're dealing with a rational expression. So specifically, you always want to try to factor everything before you perform any operation. Today we're just looking at multiplying and dividing, but this will also be true for adding and subtracting. Always factor first. Now for multiplying and dividing, we will not need a common denominator. I do recommend looking for any common factors in the top and the bottom of your fraction, because if you have the same factor on top and bottom, you can actually cancel those out when you're multiplying. That will not be true when we look at adding and subtracting in the next video. Once you've canceled everything you can, you're just going to multiply straight across. And when I say that, I'm referring to you doing the numerator times the numerator and also the denominator times the denominator. Don't mix anything around like do top times bottom or from bottom to top. It's top times top and bottom times bottom. And then when you get a division question, you actually just want to use that rule a lot of you learned as keep, change, flip. I like to say this a little more formally as multiply by the reciprocal instead. So instead of dividing something by 2, you can multiply by 1/2. Just flip the second fraction upside down and change the operation to multiplication instead. For this first example, I'm not even going to do one where we're actually multiplying and dividing. I want to instead focus on just a single rational expression and see what kind of simplifying we can do within that one expression before we multiply multiple rational expressions together. So the first step I asked you to perform is to do any factoring that you can in the top and the bottom. So every fraction, look at the numerator and denominator separately and factor everything as much as possible. The first factoring technique you always want to look for is the GCF. That's the one you'll probably use the most. And I see that both of these terms are divisible by x. So I'm going to take x out. And then that will leave behind an x plus 4. So remember, if I'm taking x out, I'm saying what's x squared divided by x and what's 4x divided by x. If you want to check your factoring, just quickly redistribute. If I multiply this out, I would get x squared plus 4x. So that's how I know I did this correctly. Now we'll do the same thing in the bottom. We'll see if there's any factoring that can be performed down here. And again, this looks like another GCF case. But instead of taking out an x, I'm going to take out 5 because both of the numbers are divisible by 5. So 5x divided by 5 is x, and 20 divided by 5 is 4. After factoring, you want to look for any common factors that you have in the numerator and the denominator. In this case, I see that I have the entire factor x plus 4 in both the top and bottom of my fraction, so those things can cancel out since these aren't being added or subtracted. When you're multiplying factors, you are able to cancel part of the product out in this case. So my final answer is what I have left, x divided by 5. Now we'll actually do a multiplying rational expressions question. So a lot of the steps look the same, it's just I'm doing them twice and having to multiply straight across on the fractions. First step though, we want to factor everything we can. So I'm going to start with this top left piece, and I see what looks like a GCF. Both of these terms are divisible by 3x. So if I'm doing 18 divided by 3, that would be 6, and x squared divided by the x I'm taking out would leave behind an x. And be very careful about this part. A common mistake students make is they say, oh, I took 3x out, so there's nothing left. But remember, we're dividing by 3x. So negative 3x divided by 3x is negative 1. So don't forget that you should be able to see your factorings correct by multiplying it back out. If you ended up with just one term inside, then it would be impossible to redistribute and come back to 2 terms like this. Now on the bottom left, there's no factoring to be done because we just have a single term, 3xy. Same thing for the other fraction. So now if we write the multiplication symbol, in the top right, I have one term. So there's nothing to factor there either. The bottom denominator, the right side denominator, does have 2 terms, but I don't see anything that factors here. So I'm just going to leave that as 6x minus 1. So not everything will factor. That's okay. Now that the factoring is done, we're going to look for common factors that match in both the numerators and denominators. So within this fraction on the left-hand side, I see a 3 times x times something, and on the denominator, I see 3 times x times something. When you're multiplying, it's okay to cancel out part of it. So I'm going to cancel out the 3 times x with the 3 times x. But you can also look at the adjacent fractions, so the two fractions that are being multiplied. I can also look at common factors in the top and bottom of those when they're being multiplied. So I see a 6x minus 1 and a 6x minus 1. The entire factor has to match for me to do this. I couldn't have done just like 6x with 6x minus 1. I couldn't have canceled out part of it. The whole factor has to match like that. And then there's actually a little bit more I can cancel here, because the numerator of the right side fraction, I have y squared, or y times y, same thing, and I have a single y in the denominator of the left side fraction. So I can cancel one of the y's with one of these y's. So I'm just going to mark out the exponent to make sure I remember that there's still another y left in this numerator. Now that I've canceled out everything I can, let's do the multiplication and write down whatever is left. Don't forget that when you are canceling things out, you're saying 3x divided by 3x is 1. So it's not leaving behind zeros. Sometimes I see people place zeros in behind, but then that would clear everything out once I get to the multiplication step. Instead, this is just going to be a 1 over 1 times 12y over 1. So my multiplication for this one is very simple. Since I'm just multiplying a bunch of things by 1, there's actually very little left. So on top, I have 1 times 12y, and in the bottom I have 1, because everything canceled, times 1, because everything canceled there. You don't need to write 12y over 1 though, your answer would just stay exactly as that. One more example, this time we are doing the division operation. So I'm going to do my factoring here in the top left. I'm going to take the 7 out for a GCF. Remember to check if your factoring is correct. That would give me 7x minus 7y, and that works. In the bottom left, there's no factoring. I just have the one term, so 4y. Now remember, whenever you have a division question, I want you to change this to multiplication and then flip the fraction upside down. So I'm going to do my factoring and my flipping at the same time. So what used to be in the bottom was 3y. That cannot be factored, but because I'm changing the operation, now it's on top. And again, I'm flipping the whole fraction, so the top is going to move to the bottom, and I'm also going to do my GCF at the same time. If you want to do this 2 separate steps, feel free. So I see that there's a GCF. I can take 14 out of those, and that would leave me with x minus y. So I've done 2 steps at once. I've done the multiplying by the reciprocal instead of dividing, and I've factored everything at this point. Next, I'm looking for any common factors in the numerators and the denominators. Well, an easy one to spot right away is the whole factor x minus y and the whole factor of x minus y. It's on the top and the bottom of 2 fractions being multiplied, so that's fair to cross out. Next, I see a y in this numerator and a y in this denominator, so I can cancel those out. And then there's one more thing I see I can cancel if I'm looking at the numbers. 7 and 14 also are both divisible by 7. So if I'm reducing those fractions, I can change this to a 1 and this to a 2. It can get kind of messy when you're doing a lot of canceling like this. That's why I'm trying to make sure we practice and you're not getting kind of lost in what you've marked out and what you haven't. You have to be very clear about what's canceled and what's left. So at this point, I believe I've done all of the canceling out that I can. So I'm going to go ahead and multiply straight across on my fractions. All of this numerator was gone, so I have 1 times, and the only thing left here is a 3. In the left side denominator, all that was left is 4. Everything else got canceled. And on the right fraction denominator, all that was left was a 2. Because remember, I took the 7 out of the 14, but that still left behind 2 there. So on this one, when I multiply straight across, I get 4 times 2 is 8. So that is as reduced as this fraction can get. If you see that this can be reduced anymore, then it might just be that you missed some factors that could have canceled. That's okay. Then just simplify it again from this point instead, and maybe that'll be a little bit easier in case there were a whole bunch of factors to look at and compare. So that's it for how to multiply and divide rational expressions. Next, we'll be looking at adding and subtracting.